where sounds twist and snag, echoes of the past, blending new crafts.
Hello everyone. In this video I will be talking about capacitors and capacitors in audio circuits, their importance, and in the perspective of repairing, what should I consider and take in count when I am changing old capacitors to the new ones, and what should I be aware of. Capacitors in audio circuits, they are the crucial components, and they are very important components in the circuit. And they should work as they are intended to. And of course, that's why we want to have the best possible capacitors in our circuits. This will be a little bit of a technical talk, and I will show you some thoughts of mine. And the main issue today, which I am going to talk about, is the leakage. Now, especially when we are working with tube electronics, which one I do have here now in my bench, my tube amplifier project, it is very important that those capacitors I'm installing in the circuit, they don't leak at all. That's because there is huge voltages over those capacitors in that particular amplifier on my bench. Now there are 400 volts or even more for some capacitors voltage across the component, DC voltage. So that capacitor must be in the specs, and it has to maintain its properties so that it can take that voltage over its leads. Now, some older capacitor types are notorious for leaking, and especially when they are old enough and they have been used a lot, and they have been used in high voltage circuits, they will get leaky by the time. And it's now very important that we are testing and finding out those leaky capacitors and taking them out of our circuits. But let's talk about the leakage for a while, what it means and how it affects the electrical circuit. Now, when we are looking at the capacitor, it's not only the capacitance which we are talking about. The capacitor never will be the perfect capacitor only. It will include the capacitance, and also in series with the capacitor, in electrical way, there is a little bit of inductance and some resistance. Now, these three parameters are pretty easy to measure with a proper meter called LCR meter, and I do measure these parameters of capacitors. But then there is a leakage part. And how does that leakage influence to the capacitor? It goes here. It is in parallel. It is like a parallel resistors for the capacitor. Now what happens? If we apply voltage over the capacitor, here and here we are applying high voltage, like 400 volts or something like that. There will be constant current flow because of this leakage resistance inside the capacitor. And what does it do? What does it do? When we are using this capacitor for a coupling purpose, in particular tube amplifier application, it will allow the next stage tube to open and overload all the time. It's not good for that circuit that the voltage will rise in the other end of the capacitor. And the tubes will degrade and eventually destroy itself when they are overloaded all the time. But there is no way that I could measure this leakage with that standard LCR meter, because it is not going to. That LCR meter uses only low voltages in a measuring circuit. And there's no way that I could apply 400 volts over the capacitor, which I need, that I can measure this resistance. And the reason why I cannot measure the leakage current with the low voltages is simply because that component will not leak if I only apply low voltage over the component. It needs that high voltage when it starts leaking. It breaks down and leaks. So I need to apply the high voltage. Now, truth is, there are commercial devices for measuring this leakage current, but they are rather expensive for my little lab and hobby works. I don't think I'm going to purchase that kind of equipment any day soon, but I'm going to show you how it is pretty easy to DIY this kind of device. If you look here, this is my leakage current measurement device. And what do I do? What do I need here? If you look carefully what we have here in the box, there are a couple of power sources, and one of them is just regular 12 volts AC to DC power supply, very cheaply made Chinese power supply, but it works okay. And I also added some noise suppression here in the power cord, if it makes any earth noise to my power lines, this suppresses it a little bit. And then we have here the upside in this device, we have this high voltage power supply. It converts DC 12 volts to up to 400 volts DC output. Also, little Chinese device and works okay. I'm not sure if it is the best quality available, but in this case, in my laboratory, in my lab, it is okay. This is just a hobby, so I think it's just fine for some measurements here and there. And then I made myself this little board here, which includes one transistor, some resistors, and then this variable potentiometer here. I can adjust the voltage from 30 or so volts up to the 400 volts. And then I'm going to add my multimeter with a microamp scale to these tabs, and the capacitor itself, it will go to these leads. And then I can apply that 400 volts over my capacitor for testing and measure the leakage current. There's also a place for a little warning here. If you are not familiar with those high voltages, do not try to do this at your own home. Everyone is responsible of the actions to make. Just remember, there are very high voltages in this device. I showed you up to 400 volts, and you can get really badly jabbed. Remember, if you like my videos, please thumb up and consider to subscribe my channel in the future. I will make these videos again. And soon I will continue with my project and show you more of my amplifier restoration. But before that, I think I am going to install this new device I just made. I will put it in my bench and I show you some measurements from that amplifier, from those capacitors from this amplifier I'm restoring. For now, I hope everyone peace and happiness, and see you soon.